Okay, so um, hello everyone. So this is our transportation network system. This is for um, creating uh, a network system for multiple use. For example, for logistics, or simply just a learning tool for students. This transport system showcases different algorithms that you could use, so it is a good learning tool if you intend to use it that way. So what we have here is that we have a map. We have different action buttons or actions you could use, and this is the help for understanding um, the different functions of the system. So as you can see here, you can see the different information on the help button. So first we could move the map here. We could zoom in, zoom out. So this is a map used. We used Leaflet as our map. This is a JavaScript library for interactive maps. So, but what you could do here is you could edit graph or move map. So, if it is on the move map operation, then you are able to move the map as you please, and you cannot press the buttons as it is deactivated. So when you press the edit graph, you aren't able to move the map, and you could add and you could access the different functions of the buttons. So for example, we could also search a location. For example, let's search Bacolod. Okay, so this is Bacolod City, as you can see here. So let's find a simple street that we could create a system or a network of nodes and vertices or paths. So when we edit graph, we could add a city. Let's just call it points, for example. The buttons, as you can see here, is add city and remove city, because this is intended for larger mapping of areas. For example, Bacolod City, Bago City, but you know, it is also applicable for small scale mapping. So for example, let's do it here. Edit graph, we could add city, let's say point A to A. I could add one here for B, C, and D. Put one here as an E. F right here, and something like this. Okay, so add roads to connect the cities. This is just pure this isn't accurate, so you could just place whatever you want. But for in the correct way of using the system, you should have the resources to properly identify the distance between point A and point B. You could use Google Maps or whatever, but here in our system, you have to manually add the distance, because so that it, just to show, or in a way it could be used as an educational tool or a learning tool in understanding different algorithms. So you could play with it. So here, let's say 10 kilometers. Add here, let's say 2 kilometers. E to F, let's say 4 kilometers. D to E, say 3 kilometers. Say 8. One and 2. So you have seen the add city function and the add road function. You could also remove a city like this. When you press remove city, just click on the node you want to delete, and it would delete the node as well as the road. So let's put it back in the C and add road. Say 9. Also, you could remove a road like this, or you could also undo or redo, and you could also clear the graph. So we are not going to clear it right now. We are going to test the different algorithms. So Dijkstra finds the shortest paths from a start city. So when you run the algorithm, it's going to ask you start city. So let's say we're going to start with city C. As you can see here, it shows the different cities you could go to and how you could go through go to the different cities, and the distance from that city to from the start city to the city you plan to go to. So for example, to A, here 14 kilometers, you go to C, C to D, D to E, and E to A. To B, C to D, D to E, E to F, F to G, and G to B. So it would show all the shortest distances you could follow to go to a city, and this is the steps, the iteration of steps, so that you could get insights on how it works. For the prims is finds the minimum spanning tree. So when you run the algorithm, so here the distance between A to E is 2 kilometers, D to E is 3 kilometers, E to F is 4 kilometers. It basically shows the distance from each city, or between cities, I mean. For example, C, what is the distance between C to D? C to D is 9 kilometers, so that's Prim's. Ford-Fulkerson is calculates max flow between two cities. So enter a source city, let's say C, source let's say A. Maximum flow from C to A is 1. So let's show TSP. Let's put that as last. So let's work on the DFS first. DFS is the first search traversal. So what it would do is search the network using DFS. So let's start at CTC. So it would go to go through all the networks, so that it would be able to visit all the cities. So first is you go to C, then D, then E, then A, then G, B, G, and F. So what would happen if, let's say, I remove a road here? So what would happen is that it would, as you can see, instead of going to AD, what it did is it went from D to E to A, going back to E to F, G, and B. So that is how it works. And for the TSP, or Traveling Salesman, this finds the shortest route visiting all the cities. So to be able to go through all the cities, it would create a path in which you have the shortest distance or travel time, or travel distance, I mean. So when you run the program, the optimal TSP route is A to B. For example, starting from the first city that you placed, which is A. So A to B, B to G, G to F, F to E, D and C, and back to A. So the total distance is 42 kilometers. So starting from A and going back to A, the shortest distance is 42 kilometers. So that's it. You could clear the entire graph, as you can see here. And yeah, that is our transport system. Thank you.